In this one, we will see various commonly used operations on a vector. Suppose if you are given the sales data of a company, you will first want to find out more about that data. Things such as what is the median, what is the mean, what is the maximum and minimum values, and so on. These are all called summary statistics. You will also want to have a complete control of how to manipulate this data. For example, you will want to sort this data, find out the unique values, find out the duplicate values, find out what are the various quantiles of this vector. These are all things that you need to know in order to have a complete understanding and control of the data that you are having at hand. Let's begin with the clicks28 vector. Clicks28 represents the number of clicks coming into the online pizza company's portal. It is a random number that varies between 3000 to 4000. We also have a couple of missing values and an infinite value into it. This is what it looks like. Now let's do some single vector operations on top of it. Now how to find what are all the unique values in clicks28? Now imagine you received clicks28, but if you see that in clicks28 there are not so many unique values. If all the data in your clicks vector is almost the same, it means that there is something problem with the data. In such situations, you will want to do a brief check on what are all the unique values present in that vector. We have NA infinity in place. Totally there are 26 items in this vector, but the length of the vector is 28. So this means that there must be some duplicate values present in this vector as well. So how to find the duplicates now? To find duplicates, use the duplicated function. What it does is, from the second occurrence of any value in the vector, it will mark those places as true. The first place is not getting marked as true. Now, if you pass this mask to clicks28, you will get the values that got duplicated. Now, how to find the average clicks that we got for the 28 days? Clear the screen. If you try to find the mean of this, mean is the function to compute the average. And if you look at the value, it shows NA. The reason is there is a missing value in the vector. In such situations, most single vector functions will return an NA. Likewise, most single vector functions will also have this argument called na.rm. You need to set it as true in order to get rid of the missing values. Now if I check avclicks, it shows infinity because clicks28 contains an infinite value. So mean of any infinite value is always infinity. To remove infinity, I am using the is.infinite function, negate it, and then store it in clicks28 noinf. Now NA is present here but no infinity. Now I'm going to remove the missing values using is.na and negate it, and then compute the mean on top of that. So this is one way of removing the missing values. Alternately, you can use na.omit function also. Now clicks28 noinf no na does not have any missing values or infinite values. Compute a mean of this, you will get avclicks. Now this is one way of working, that is we are storing whichever intermediate value is there in another vector and then doing the mean of that. This is one way. Another way to do it is apply mean on this function directly. This also will give us the result. The downside is if you are nesting functions within functions, it becomes harder to read. That is a downside to it. But the upside is in previous approach, we are creating and storing a intermediate vector in memory. This is occupying some sort of memory space. Right now, this is a small vector, so memory doesn't matter so much. But if you are working with a very large data, then you must take these aspects into consideration. You don't want to block your memory by storing too many intermediate objects. So keep that in mind and make your code accordingly. Now let's see how sum works. That is finding out the total number of clicks in that month. If you do sum of this, we have 87,000, 88,000 approximately. Now, how to do sorting? Now I know the sum and the mean. Now I want to sort it. By using the sort function, it will arrange the numbers in ascending order by default. To make it arrange it in descending order, set decreasing argument to true. Alternately, if you reverse the sorted vector, it will turn to reverse sorted, decreasing order. The output of sort set with decreasing equal to true and doing a reverse of the sorted vector is the same. Now, one more method to sorting. This is a very commonly used approach. There is a function called order which returns the positions of the items after sorting it. Now, if I see the output of order, it says 4, 23, 16 and so on. What this means is to make the clicks28 no inf no na vector in ascending order, you need to place the fourth element in the first place, 23rd element in the second place, 16th element in third place and so on. This is literally the output of order function. Now if you place this output inside square brackets, you will get the vector in a sorted order. This is a very commonly used approach to sort a vector by R programmers. Even though it may look like additional work, this is often used and tends to work a little bit faster. I need to confirm that statement because I haven't tested it, but the understanding is it works generally faster than using the sort function itself. To make it arrange in descending order, add the minus sign just before ordering it. Now let's find the quantiles. The 50th quantile or the 50th percentile of any given numeric vector is called the median. Let's compute that using median function. Alternately, you can use the quantile function probes argument to 0.5 and you will get the same value. Now, besides median, sometimes you will also want to know the 25th and 75th percentiles. To compute that, pass 0.25 and 0.75 as the second argument. Alternately, you can pass all these percentiles that you want to calculate as a vector and then pass it. This will also work. A nice way to summarize all of this information in one single function is use the summary function. It gives the minimum, first quantile, median, mean, third quantile, max, NA values. Now let's do a mini challenge. So this is the challenge for the video. We have the age of 7 kitchen employees, of which one of their age is missing. Now find the mean median of these employees and also find the value and position of the second highest age. Give it a shot in your RStudio. I will show you the answers after a short pause. So here's the solution. Average and median age. To compute the position of the second highest value, this is the value of the second highest. Hope you got that right and we are making good progress now. Let's meet in the next one.